Now we'll discuss first and second derivative test to find local maxima or local minima of any function. So first we'll see first derivative test. So if f of x is any differentiable function in the interval I and a belongs to I, okay, then x equal to a is said to be point of maxima. X equal to a is said to be point of maxima if f dash of a should be 0, one thing, then f dash of x is more than 0, okay, for all x which are less than a, and f dash of x is more than 0, less than 0 for all x which are more than a. See, we see this graph here. At a, if we draw tangent, then it is parallel to x-axis, means f dash of a is 0 here, and it is our necessary condition. F dash of a should be 0 for local maxima or local minima. So f dash of a is 0 here. Now all the points which are less than a, if we take here, at this point, this point, this point, this point, है ना? If we draw tangent of this function, then its slope will be positive, okay, means f dash of x is positive. Slope means derivative of this function. So f dash of x is more than 0 for all x which are less than say, because here function is increasing here, है ना? So here derivative of function is more than 0. Then after a means all the values will be more than a. So if you take this point or this point, if you draw tangent, then what happens? Slope of this line will be negative, means this function is decreasing. So this derivative of function changes sign from plus to minus, means f dash of x is more than 0 for all x less than a, and f dash of x less than 0 for all x more than a. Then the point is called point of maxima, okay? And if x at x equal to a, point is called minima, point of minima, if f dash of x is less than 0 for all x less than a, and f dash of x is more than 0 for all x more than a. If we see this graph again, at this point a, f dash of a is 0, then here if you take this point and we draw tangent, its slope will be negative. It means at every point, it means this graph, this function is decreasing. And here if you take this point or this point, if you draw tangent, its slope will be positive, means this side it is increasing, means sign changes from minus to plus. F dash of x is less than 0 when x is less than a, f dash of x is more than 0 when x is more than a. Then x equal to a is called point of minima, okay? And if x equal to a, at x equal to a, f dash of a is 0, okay, but f dash of x does not change its sign, means it remains plus to plus or minus to minus, then at x equal to a, function has neither maximum nor minimum value, and this type of function, this type of point is called point of inflection. This point A is called point of inflection if f dash of x is 0 and f dash of x does not change its sign, means it remains plus to plus or minus to minus. So this is our first derivative test, okay? You can note on this. Then we'll see second derivative test. Now in the second derivative test, and in the first test we have to find some points where value of derivative of first derivative, so we have to see less negative or positive, positive, negative, na? But here in the second derivative test, f of x is any differential function in the interval I, then x equal to a is called point of maxima if first thing f dash of a should be 0, and second derivative, and name of this test is second derivative test, means we need second derivative also. So value of second derivative at x equal to a is negative. Point of maxima and value of second derivative is less than 0. So this test also called, we can say, opposite test. We get value of function maximum if value of second derivative at x equal to a is less than 0. And if f dash of a is 0 and f double dash of a is more than 0, first derivative 0 at a and value of second derivative at a is more than 0, then x equal to a is called point of minima. For minima, value of second derivative more than 0. For maximum, second derivative value less than 0. Okay? Then if f dash of a is 0, f double dash also 0, then we cannot say at x equal to a what we get, maximum or minimum value. So to again see the first derivative test. So these are the steps to find. And what we'll do, we'll find derivative of function. First step is find the derivative of function. Then put equal to 0 and find the values of x. There may be one value, two values, three values, depend on the function. Then we'll find second derivative value at these points. We'll see negative, positive, or more equal to 0. What happens? Then according to the condition, we can say the point at x equal to x1, what will have, maximum or minimum value. At x equal to x2, what will have, maximum or minimum value. So steps are, first find derivative function, first derivative, then put first derivative 0, find values of x, then find second derivative and put these values in this and see the sign of second derivative. Okay? Mostly we'll use second derivative test. It is easier than first derivative test. Okay?